Now let's look at instructional systems. And an instructional system is everything that makes up an instructional environment. If we look at the different components of an instructional system, we see that there are clear learning objectives. There is the learning environment. There are the methods that are involved. There are the media. There is various equipment that is involved, and then there are obviously the learners and the instructor and other people involved in the learning process. There are also characteristics of the instructional systems, and that is direction, the synchronization. Is it synchronous or asynchronous? What costs are involved? What group size issues are there? What location? And how much time is involved? And all of these components and characteristics go together to make up the instructional system. Now, there are many categories of instructional systems. First is cooperative learning. Now, there are a number of advantages to cooperative learning. First, these include they are very active, they are very social, they are very interdependent, and it allows for individual accountability. Now, one of the issues here is that how is this individual accountability addressed? So some of the limitations include student compatibility and how well students work with each other, student dependency, or one student or multiple students in a cooperative learning group depending too much on others, or one kind of dominating the learning environment. They can be very time consuming, so it's always quick and easy for a teacher to present to the class a bunch of information, but it takes a lot more time, a lot more work on the instructor's part to provide these cooperative learning environments. Having individualists and people that don't work well together is an issue in addressing those. And then there are a number of logistics issues. What size groups do you make? How much time do you allot? Or do you have enough equipment? All of these sort of things. In the integration process, it's important to address some of the typical issues with cooperative learning. And the one is students breaking up and doing work independently and then kind of coming back together. So if you had 4 items that students were to explore, instead of looking at the 4 items and working together on it, a typical issue might be that one person is assigned one, a second person is assigned the second part, etc. And then there's no real collaboration or cooperation there. It's independent work all thrown together. So to address this, it's important to promote interaction in the actual learning environment. One issue with this is interdependence, and having these different elements depend on one another is very, very important so that they cannot work independently. There are certain aspects that can be independent, but everything depends on each other, so it's important to bring these back together. And then this is a very constructivist learning environment, so it's important that knowledge is constructed and it's not a very behaviorist type of situation. Some examples of computer-based cooperative learning and online collaborative learning you've experienced in online courses include chats, discussions, and other collaborative software such as wikis, blogs, those sort of things that you may have had some experience with, and things that we'll explore more as you move through the program. Now, another category are games and gaming, and some advantages of this include that they are attractive and fun for the learners. There is definitely a novelty effect, so it's new to most learners and using games for instructional purposes. The atmosphere is very engaging to the learners, and a lot of time is spent on task in the learning environment. So it's very fun, it's very novel, so there's not a lot of time spent exploring other issues and non-instructional issues there. A couple of limitations is that it promotes competition, which can be a good thing, can be a bad thing. Many times the gaming environments can be distracting, and oftentimes also, while this is improving, but games are can be very poorly designed, especially instructional, educational games. They don't quite have the budgets that commercial games do, so this can become an issue. Some integration issues to concern or to address include adding motivation to the learning environment. So the game selection needs to include something that's motivating, something that's useful, not something that's kind of bland, poorly designed, etc. One of the biggest things that you will see turn a student off of gaming is a poor design and a lack of this motivational element or a hook. They can be very good for basic concepts, and there's some actual research going on now exploring the use of games, MORPEGs, massively multiplayer online role-playing games. You may have heard of World of Warcraft or things like that, to address more complex issues and concepts such as citizenship education and civic leadership. And these are also good for small group instruction, so having individuals work together in small groups. An easy adaptation of the content for instructional games issue to consider is using familiar games. And many of you probably have done some sort of Jeopardy game in the past, and this is something that's very easy to do using PowerPoint. It's something that the students are familiar with, so there's that kind of comfort level there. One issue that you want to definitely not do is there shouldn't be a lot of time spent learning the game. So they shouldn't have to be focusing on learning the game and learning the content. It should be something that's relatively simple. So let's look at simulations, and there's a number of real advantages, real significant advantages to simulations. They are realistic, they are safe, they can be simplified, or they can be very complex depending on the learner, and can be very cost effective. So issues that cannot typically be addressed in the classroom can be done through simulations, providing very realistic, safe, simplified, cost-effective scenarios. For example, if you look at the Louvre online, they have a very nice simulated Louvre, a very virtual reality type Louvre online. Very, very nice. Frog dissections can be done easily. If you want to get into more complex issues, there's a nice cow's eye dissection. There's a nice simulation which shows the effect of caffeine and sleeping pills on the heart rate of a water flea that's online, and those kind of things can then spark in discussions of how these issues affect other things. Some limitations with simulations is that they can be very time consuming, and unless done well, they can oversimplify complex issues, and that is a real issue. Some issues to consider when integrating it is that many times simulations require more complex skills, so it's important through the social process and grouping people together, if you're using that, to group more knowledgeable others with less knowledgeable others, so having different people of different skill levels and knowledge levels and experience levels. Social interaction is important to include in the integration process, so having them do something with the simulation that promotes social interaction and also promotes decision making. So not just going through and doing a simulation or viewing a simulation or whatever, but having them interact with each other and solve some issue, some problem. There are some really good simulators out there, and another non-technical or less technical version of simulations are role play, and having students perform some sort of role play in the learning environment can be a very beneficial form of simulation. Here we see that there is this overlap between instruction, simulation, and games. And simulations can be instructional and can also be games. Instruction can include simulations and can be a game. And gaming can be instructional and can also include simulation. So we have these overlaps between each of the two elements, and then also the smaller overlap, ISG, in the middle that includes the three of them. And all of these can be done independently, but can be included together to be a component of the instructional system. So let's look at some categories of instructional systems here and how they relate to the learning theories that we've looked at. And the first we're going to talk about is programmed instruction. And programmed instruction really focuses on the operant conditioning learning theory of Bandura and also reinforcement theory. And there are a number of advantages of programmed instruction. These include it can be self-paced, so learners can move at their own pace with this. It also provides a variety of opportunities for both practice and feedback, so the learners can learn through that practice, being that active involvement with the content, with the topic, and then also learn through that reflective feedback process as well. It can be very reliable and is a very effective form of instruction for many types of learners. Some of the limitations include the program design. So is it a linear or a branched program? And this is important to consider when working with different learners and learners of various experiential level, both with the content and with the technology, and also with different instructors. It can also be very tedious. Sometimes it's difficult to include elements that get rid of or move these elements of flexibility that allow learners to go from one area to the other without going through the tedious process of stuff that they may already have expertise in. And typically programmed instruction is an individual learning environment, so this lack of social interaction can be limiting. When integrating it, it's important to consider to include multiple levels, and also, it's very good to integrate multiple subjects and sort of this interdisciplinary aspect of the learning system. It can be very useful for remediation. So if a student does not successfully meet all of the objectives, a programmed instruction tool is very good to kind of walk them through some of the areas where they had problems. It's very easy to program to create branched programs, so if a student misses something, they can move from one point to the next, or if they get it correct, or they can move from one point to a more complex point. And also consider chunking information in steps, so bringing small groups of information together as opposed to massive amounts of quantity all at one time. You want to chunk it into small groups, maybe have some assessment, some practice, some feedback, and then move on to the next group of information and steps. There are two real types of program. The first is linear, in which you just go from 1 to 2 to 3 to 4 to 5 in a very linear fashion. And then there's a branch program. And branching is your next step is dependent upon what occurred in your previous step. So if I have step 1 and I have some sort of question at the end of step 1, if I get the correction, if I respond one way, I go to step 2. If I respond another way, I go to step 2A. If I go to step 2 and I respond one way, I go to step 3 if I get it quote-unquote correct. Maybe if I get it incorrect, I move to step 3A, which I go through some remediation process and branch down. So the branching program is very useful for individualizing instruction. Next, we have program tutoring, which you obviously will be reading about in the book, but it's one-to-one interaction. The tutor's role is something that is clearly defined in the learning materials. So both the learner and the instructor/tutor know what they're doing and know their role in the teaching and learning environment. And one of the benefits is that it's very situational. So it can be very contextual and very useful for providing this very specific instruction. Some advantages, like programmed instruction, it is very self-paced. Opportunities for practice and feedback are there. There are social reinforcers here, which is how this primarily differs from programmed instruction. So the tutor is the social reinforcer. And then it is also reliable and effective for many different levels of learners. Some limitations that is very labor-intensive, including the addition of the tutor, and is also expensive many times to develop. These are just a couple examples of instructional systems, and we'll talk about more as we move through the program.